So today I'm covering section 4.5, which is we're going to learn how to solve exponential and logarithmic equations. So first, in order to solve exponential equations, we have to know the equivalence property. So if b, x, and y are real numbers, with b greater than 0, and b is not equal to 1, then b to the power x equal to b to the power y implies that x equal to y. So basically, if you have the same base, b denotes the base, then the powers are going to be equal. So this is the equivalent property we are going to use to solve exponential problems. So number one, solve 5 to the power 3x minus 1 equals 125. So now look at the base 5 here. So we have to see if we can write 125 in terms of 5. So if you multiply 5 3 times, then we get 125. You have to use your calculator and look at the base and multiply 5 2 times, 3 times, 4 times, and see which we are getting 125. So now we have the same base. So we're going to use the property, the equivalent property. If the bases are same, then the powers are going to be the same. So now we are going to solve for x. So add 1 both sides. So we get 3x equal to 4. Divide by 3. So we get x equals 4/3. So we got the solution. Number 2. Solve 1/4 equal to 8/x. So when you look at the numbers, you can say 4 is 2 to the power 2 and 8 is 2 to the power 3. So once you practice more problems, you will know the base and how to write them as powers. Now 1/2 square is 2 to the power negative 2. And when you have the power raised to the power, you have to multiply them. So we get 2 to the power 3x. Now we have the same base. That means the powers are going to be equal. So we get negative 2 equals 3x. So we get the x by itself by dividing both sides by 3. So we get x equals negative 2/3. Number 3, 8 to the power x plus 3. So just like the previous problem, I can write the 8 as 2 cubed and 4 as 2 squared. So now you have to write, when you have to multiply the powers, So we get 2 to the power 3x plus 9 equals 2 to the power 10 minus 4x. Since we have the same base, the powers are going to be equal. Now we are going to get the x by itself. So let's collect all the x together. So we're going to add 4x both sides. So we get 7x plus 9 equal to 10. Divide by 7. So we get x equals 1 over 7. So this is the first objective. So we have all the bases. We are either the bases are equal or we are trying to make the bases equal. The next point we're going to see the bases are not equal. So in order to solve these equations, you have to isolate the exponential and take log on both sides. So I'm going to show you the next one. So we have 2 to the power x equal to 7. So now I can't write 7 in terms of 2 because this is an even number, this is an odd number. We cannot raise the power. So in this case, we have to take log both sides. You can take log or ln both sides. So I have to put log 2 to the power x equals log 7. So we remember the power property for the log. We have to move this x to the front. So it's going to be x times log 2 equal to log 7. So we have to get x by itself. So we have to divide both sides by log 2. And log 7 over log 2. Use your calculator and you're going to write approximate to 4 decimal places. Enter this one on your calculator. We get 2.8074. Even if you take ln or log, you get the same answer. So let me solve the next example, number 5. So we have 3 to the power negative 0.02x. Now we can convert. So I'm going to take ln both sides to show you how to take ln. So ln both sides. Again, you can take either log or ln. So it's going to be ln 3 to the power 0.02x equals, remember you have to take ln both sides, don't forget that, and move the power to the front, times ln 3. Now divide both sides by ln 3. So we can get the value of x. So ln 0.07 over ln 3. Now I have to move this negative 0.02, so you have to put times negative 0.02 in the denominator. Okay. So these two get cancelled, so x is going to be negative ln of 0.07 over I move the negative to the numerator and round it to 4 decimal places. So this is what you get. Then get the answer using the calculator. Number 6, solve 4 plus 3e to the power 2x equal to 11. So for step number 1, you have to get the exponential by itself. So we're going to subtract 4 both sides. So we get 3e to the power 2x equal to 7. Again, I have to get the e to the power 2x by itself. So we have to divide by 3 both sides. So we get e to the power 2x equals 7 over 3. Now since the base is e, it's better we take ln instead of log. So it's going to be ln into the 2x equals ln of 7 over 3. So when you move the 2x to the front, we get ln e. And remember, ln e is 1, so this is going to be 1. So 2x equals ln of 7 over 3. Put this one on your calculator and divide by 2. So we get x equals 0.4236. Okay. So next one, we are going to learn how to solve logarithmic equations. Solving equations, so we're going to learn about the equivalence property of logarithmic expressions. Equivalent property of logarithmic expressions. Just like exponential, if we have the same base, and if you have log on both sides, I have log on both sides and I have the same log, then we can say x equal to y. So the condition here is we have to have log on both sides. If we don't have log on both sides, then I'll show you how to solve those problems. So number 9, I have log 5x minus 1 equals 2x plus 17 to base 2. So if you look at that, I have log on both sides. You have to have one single logarithm on both sides. You cannot have two log. We will learn what we have to do when we have two logs. And I have the same base 2. So in that case, these two are going to be equal. So we can say 5x minus 1 equal to 2x plus 17. Now get the x by itself. So I'm going to group the x. So we get 3x minus 1 equal to 17. Add 1 both sides. So we get 3x equal to 18. So I'm continuing here. Divide by 3. So x equals 6. So you can always check your answer by going back and plugging it back in the original equation. So next problem number 10. Solve So we have the, see, the base, there's no base, that means the default number is 10, and we have log on both sides. That means we can say x minus 7 equal to 5 minus x. So let's solve for x. So add x both sides. And add 7. And divide by 2, which gives x equal to 6. However, we have to go back and plug it in the original equation. So we have log of 6 minus 7 equal to log of 5 minus 6. However, we are getting log negative 1. Log of negative 1 is not defined. If you enter on your calculator, it's going to give you an error because log of any negative number is not defined. So in this case, there is no solution. So for all the logarithmic problems, you have to make sure you don't get any negative log of any negative number. So we have to always go back and plug it in and see if it works. So number 11. So now look at this. In the beginning, I said you have to have only one single logarithm. So now I have two logarithms, right? And so since I have two logarithms, I can put this one into one single logarithm by using quotient rule. Because it's minus, we have to apply the quotient rule. So the first one goes to the numerator and the second one goes to the denominator. So now I have made the two logarithms into one single logarithm. So now I can say 3x, this is, let me write the by, this is by the quotient property. Apply the quotient property. So now I have only one single logarithm on both sides. So now I can say 3x minus 4 or x plus 1 equal to 2. So this is a rational equation. So we're going to solve by putting 1 in the denominator, then do the cross multiplication. So 3x minus 4 times 1 equals 2 times x plus 4. And then distribute and solve for x. We get 2x plus 8. And then subtract 2x both sides. So we get x minus 4 equal to 8. So x is going to be, sorry, there's a mistake I made here. It's 1, I put 4. 1, so this is going to be 2. So we get x equals 6. Okay, next problem number 12. Solve. So we have two logs here, so we have to see what property we can apply here. Since there is the middle sign is plus, we have to use the product property. So we're going to use the product property. So which means x times x plus 3, we have to multiply them, equal to ln 10. So now I have bases on both sides, same base. So I can distribute this x squared equal to ln 10. And since we have ln on both sides and we have say bases same, so these two are going to be equal. So we have x squared plus 3x equal to 10. Now again, we have to use the factoring here because we are getting a quadratic equation. So subtract 10 both sides. So we get x squared. So the factoring we have to use for the whole course. So which number goes into negative 10? It's going to be 5 and negative 2. And set each one equal to 0. So we get x plus 5 equal to 0, or x minus 2 equal to 0. Get the x by itself. So we get x equals negative 5, or x equal to 2. However, you have to go back and plug it in here. When we put negative 5, ln of negative 5 is not defined. So the only solution is x equal to 2. So don't forget to check your solution always. Next problem is going to be a little bit different. So I'll show you how to solve this one. Here the only difference is we have the power. So we have 2 in the front. This first place, this is going to be the power of this equation. So it's going to be log x squared over 3. So we are applying the power property. So here this is the power property. Here it's plus, so we're going to apply the product rule. So it's going to be log 2 times 3x minus 4 to the base 3. So we have the same base, so it's log. So we are going to say x squared equals 2 times 3x minus 4. Again, we are getting a quadratic equation, so we have to factor minus 8 and bring everything to one side. So minus 6x plus 8. So we get x squared minus 6x plus 8 equal to 0. So we get minus 4 minus 2. Then set each one equal to 0. So we get x equals 4 and x 2, and go back and substitute in the original equation. Both is giving both solutions check, so we are good. So there are two solutions for this problem, 4 and 2. Okay, now what happens if you do not have a, if you do not have log on both sides? Then we are going to use the exponential form. So let's look at the next problem. So see, we do not have log on the other side. So how we are going to solve this problem? So what happens? We have to now convert log into exponential form. Convert to exponential equation. Remember, we learned this one in the beginning. So the base is going to be the base, and this is going to be the power. So 5 square equals 3x plus 1. So we have converted into an exponential form. We know 5 square is 25. So now we can solve for x. So we get 24 equal to 3x divided by 3. So we get x equal to 8. Then you can plug it back and you can check your solution. Number 15. Okay, so now I have log on one side. I do not have log on the other side. However, I have two logs. So I have to put it back in one single logarithm. So we can use the quotient property here. So that becomes log x plus 6 over x minus 2. And the base is 3 equal to 2. Previous problem, we have to convert to exponential form. So we change into exponential equation. So that means 3 square equals x plus 6 over x minus 2. And 3 square is 9. We are solving rational equation, so we have to do the cross multiplication. So do the cross multiplication, we get x plus 6 equals 9x minus 18 and solve for x here. Minus 6. So we get 6 equals 8x plus minus 18 and 8x minus 18 and then add 18 both sides. So we get 24 equals 6x. So x equals 4. I'm sorry. 8x. I'm going to erase this whole thing. I'm sorry. So we have 8x, I put 6x. 8x equals 24. So x equals 3. Okay, so we are going to the next problem. I have number 16. Solve so we have again log on one side. We do not have log on the other side. In that case, we have to use only exponential form. So let's first make it into one single logarithm by using the product property. So it's going to be log of x times x plus 15 equal to 2. Now I have to convert into exponential equation. So to do that, we need the base. Remember, if there is no base, the default base is 10 here. So don't forget that. So it becomes 10 square equals x times x plus 15. So we are getting again a quadratic equation. X squared plus 15x equal to 10 squared is 100. So subtract 100 both sides. So we are getting x squared plus 15x minus 100 equal to 0. So factor this. So we get x plus 20, x minus 5 equal to 0. So set each one equal to 0. Then solve for x here. X equals negative 20 and x equals 5. But log, when you go back and plug negative 20 for x, log negative 20 is undefined. So you always have to go back and check. So this is not our solution. The only solution is x equal to 5. Okay. So next question is number 17. Solve. So this is again different problem. So first you have to group all the log to one side and then move the 3 to the other side. So I'm going to first subtract log x plus 3 here to the other side on both sides. So we are getting 0 on the other side. Now we have to move the 3 to the other side. So 3 gets cancelled. So now I have moved all the log to one side and number to the other side. So that way I can apply the quotient property. Because it's subtraction, I have to apply only the quotient property here. So it's going to be log. Don't forget the base, because if I don't put the base, then it's going to be 10. The default base is 10. So I have to include the base all the time. So now let's convert to exponential equation. So that is going to be that we get x squared minus 9 over x minus 3 equal to 4 to the power 3. Now I can factor the numerator into, because it's difference of square, I'm factoring 2 x minus 3 times x plus 3. So it's going to be 64. So these two 1 second. Oh, why am I making mistake here? So it's plus 3 plus 3 with plus 3. I'm sorry. So you can cancel these two. So we get x minus 3 equal to 64 and add 3 both sides. So we get x equals 67. So the answer is x equals 6. Next one, I'm going to solve the word application problems. So it says if $20,000 is invested in an account earning 2.5% compounded continuously, determine how long it will take the money to grow and use the model A equals P times e to the power RT. So I'm going to write the amount A is given as 45,000 and P is 20,000 and R is 2.5%. Can convert to decimal. And we are going to find how many years how long it's going to take. So let's plug it in the formula here. E to the power 0.025 times t. So first we have to get the exponent e by itself. So we are going to divide both sides by 20,000. I have to get rid of this 20,000 because I have to get the e by itself. So I get 2.25 equal to okay. So in the beginning, we learned how to solve exponential equations. So we have to take, because the base is e here, we have to take ln both sides. You can take either ln or log. However, since the base here is e, I'm taking ln both sides. Now you have to apply the power rule. So we have ln 2.25. So the power comes to the front. We have to move the power to the front and times ln e. But we know that ln e is always going to be 1. So we get ln 2.25 equals 0.025 times t. Now we have to get the t by itself. So divide both sides by 0.025. So enter on your calculator, you will be getting 32.4 and you can round it to like in 33 years that the amount is going to grow up to $45,000. The last problem in this section, number 19, the formula for the relates the energy is given by an earthquake of magnitude m is given by log E equal to, there is an equation given for us and you have to solve for the whatever the question is, what is the energy released by the magnitude 6 and 7? So there are two questions. The first one, the energy is 6, and then for the second one, energy is going to be 7. So you're going to plug it in the equation. So this is the equation. So log for the magnitude, you have to find the we have to find the, this is actually the magnitude. The 6. The question is, what is the energy released by the magnitude 6 and the magnitude 7? So let's find the E equals 5.24 plus 1.44. First plug in 6. Next we are going to plug in 7. So we have to use our calculator to get them. So get 13.88. So we know that the base is 10. So E is going to be 10 to the power 13.88. So which is going to be 7.6 times. It will be answer. Next we are going to plug in 7, 4 and in the handout it says multiplication here, but it's plus. So E is, you're getting 10 to the power 15.32. When you approximate, you get 2.1, 10 to the power 5. And it's given in terms of, you have to write the unit as well. So this is end of 4.5. So I will put 4.6. Bye.